So let's begin. We're going to do the binomial theorem today. Part one, part uno. So the idea, and you'll see kind of where we're going to get to in a second here. We're going to learn a nice little trick, a nice little shortcut for expanding a lot of binomials. So this is kind of a nifty little thing to have. So we're going to do x plus y to the 0 power, that's 1. Anything to the 0 power is 1, so that's not too bad. If I go x plus y, and I raise it to the first power, that gives you x plus y, yes, okay. Good. Easy so far. Good. X plus y squared. X squared plus 2xy plus 1. That's right. X squared plus 2xy plus y squared. Cool. If you were to square a binomial, you have to FOIL it all out, right? So I don't want to write out the big expansion of that, but you have to FOIL it. So you distribute the x in there, distribute the y in there, and add your like terms. So you end up turning out to get something like that. Okay? X plus y to the third. So that's going to be x to the third, obviously. Right? We've got an x to the third power there. It's going to be plus 3x squared y plus 3xy squared.
No, just curious.
Y cubed.
Would you put y there first?
You would put either of them in the third first. What you would do for this cube is you would multiply x plus y times x plus y times x plus y, right, and FOIL all that stuff out.
Wait, if you FOIL the first two together and then FOIL
Then distribute the last
the last one into the two that you combined to do it?
Exactly.
Because I think there was a question like that on our last quiz or something like that.
There was something like that on the last
That's
one.
what I did, so that's good.
Although it was overkill, you didn't have to do it on that one. So.
I did that.
All right, so if you'll notice, there's a nice, neat little pattern that's happening on this. Should we go one more level just to try to see the pattern?
Yes.
Sure, why not? So it's going to be x to the fourth
3xy to the
plus 4
X to the fourth. I got that.
x to the third y.
Are you sure?
No, I'm not sure.
How do you know this without having?
I'm cheating.
There's a pattern.
There's a pattern.
I don't see it.
There's a pattern.
You being serious?
I'm being dead serious. Let's look at the pattern. Let's figure out the pattern for this. There's a pattern that happens on this.
At the end.
Now this is obviously okay. The ends are easy, right? The ends. You notice this is just x to the whatever power it is, y to whatever. But that's the ends, right? The inside is the meat and potatoes of all this stuff. If you notice on the pattern here, there's a couple patterns going on here. First off, if it's x squared, you're gonna basically you have an x squared and then a y to the 0 power right there. If you wanted to put that in there, this one you'd have an x and a y. Those are both to the first power. Notice they add to the 2 right there. This one technically we have an x to the 0 power and then a y squared. So we have a combination of all the x's and y's. Down here, I'd have x to the third. I've got x squared and y, right? This is y to the first. Notice those add to 3. Here I've got x to the first, y to the second. Notice those add to 3. And then this one I don't have an x, or I have an x to the 0 power if you want to think about it. Okay? If you look on this one, it's to the fourth. This one is 3, 1, 2, 2. 1, 3, and 4, right? So we're basically sliding the powers from one variable to the other. Start at the highest one for one of them, and work your way to the highest on the other one, and just make sure that they always add at the same level. Okay? Does that make sense, what I just said? Okay? Now, what about the coefficients, okay? Now, so that's the exponent. So if I want to do the next exponent, it would be x to the fifth, and I have, as far as the coefficients go, x to the fourth, y, x to the third, y squared, x to the second, y to the third, right? See the pattern for that? Okay, so we're dropping the x by 1 every time, and you're raising the y by 1 every time. Okay?
How'd you get the 6x?
We don't know yet. Not yet. FOIL that out 4 times, and you would see. I know it from the pattern, but we'll see the pattern here in a second. So, what's it?
So when you have an even number, would there be a squared minimum? X squared, y squared minimum?
Say it again?
Like, see that 6xy squared minimum?
This one.
Yeah, would there be another squared if you got to an even exponent? Like, because I mean, we have odd. I'm trying to explain here.
Maybe save it for later. Save it for later. We'll get there. The pattern will come. Okay. Now, as far as the coefficients go, notice that we had this 2 there. And a lot of people, when they square this, they just say it's x squared plus y squared. They forget about this internal term altogether because they don't FOIL it. They just distribute that 2 over the plus side. No good. No good, right? Order of operations says you can't do that, right? So we don't want to do that. We've got to do parentheses first. So add those on the inside of parentheses first. Okay, but if I look at the coefficients of this, let me just pull all the coefficients out and see what the coefficients look like. So this one looks like a 1. And then here it looks like a 1 and a 1. And here it looks like a 1 and a 2 and a 1.
Oh gosh.
Here it looks like a 1 and a 3 and a 3 and a 1.
Way too. Wait, what are these again?
Or milking matrices.
Next one's going to be 1, 4, 6, 4, 1. Okay, 1, 4, 6, 4, 1.
This is reminding me of chemistry.
Anybody want to guess what the next line's going to be? It's going to be 1,
5,
10,
10, 5, 1.
Oh, yeah.
That's what I meant.
Yeah.
Would that be 20?
You guys see it? This is obvious.
Okay, this is what's called Pascal's triangle. Okay, so this is Pascal's triangle. It's used to find coefficients for all of these terms right here. Now, unfortunately, if I wanted to find the 7th or 8th row of Pascal's triangle, I'd have to do the entire triangle to get there, right? And so I'd rather not do that. So there's actually another notation that will produce Pascal's triangle, and it's going to be the notation we're going to use. It's called the choose notation. And it looks kind of funny. It's parentheses that it looks like an ordered pair, except for instead of them being an ordered pair, they end up stacking each other on top, and they call that a choose. So on the top here, the top number for this guy is going to be, well, 0, choose 0 for your first one. 0, choose 0. This one's going to be 1, choose 0. And this one's going to be 1, choose 1.
1, 2?
1, choose. Like pick.
Oh.
Like I'm picking out of things. I'm choosing. Choose.
Okay.
Next one is going to be 2, 0. It's going to be 2, 1. And it's going to be 2, 2.
I always laugh every time you say that.
Because I think it's funny. The next one's going to be 3, 0. It's going to be 3, 1. 3, 2. And then 3, 3.
It's just another version of that.
These are identical. These are identical. But if I wanted to find the 7th row of Pascal's triangle, the 7th level of Pascal's triangle, not to go, okay, and the 7th level on this one, right? Well, the top one's at 0, and then 1, 2, 3. So if I wanted the 7th level, I would just start at 6. I would do 6, 2, 0, 6, 1, 6, 2, 6, 3, 6, 4. We can figure out what all those are, okay? Now, these choose things, you've probably never seen these before, my guess, okay? So let me explain how these guys work. Let me do, I haven't erased it yet. Do you still need something on there?
Yes.
Now, what this is basically saying is this. If I have 0, choose 0, right? If I start at 0, choose 0, that means I have 0 things, and I want to pick 0 from 0 things. How many different ways can I do that? One. There's one way to pick nothing. I can just pick nothing. Okay? That's one option. So this top number is going to be a 1. That's why that one's a 1. Okay? Now, if I have 1, choose 1, that means I have one object, and I want to pick nothing out of that, right? Well, how many ways can you pick nothing out of a group of 1? One way. So that's a 1, right? If I have one thing, and I want to pick one thing out of there, how many ways can I do that? 1. So this is still 1. If I have one object, if I say grab a remote off my desk, and I only have one remote sitting there, you can only do that one way. There's only one option to do that. If I put 2 remotes up there now, right? If I have 2 remotes, that's here. If I have 2 and I say, all right, here's 2 things, pick 0 things out of there. How many ways can you pick 0?
0.
One way. There's one way to pick nothing, and that's to do nothing. By me saying I'm not going to pick anything, that's 1. That's one option for me to do. One action for me to do. If I say choose 1, that means I have 2 things, and I want to pick one of them. How many different ways can I draw 1 from those 2? 2. So this is 2. So that's why this number is a 2 right here. Okay? 2, choose 2. If I have 2 objects, and I say pick 2 things out of there, how many can you pick? Well, you can pick both of them, and still get one option there. So that's a 1 again. Okay? Notice there are 1s all the way on the outside. Okay? Now you have 3 remotes. Okay? So if I have 3 remotes, and I say pick nothing, how many ways can you pick nothing? One way to pick nothing, right? You do nothing. Okay? If I have 3 objects and I say pick one object out of there, how many different ways can you do that? 3. You can pick 3 different things, right? Here, if I have 3 objects and I say pick 2 of them, how many different ways can you pick 2? Well, if I have 3 things here, right, I can pick these 2. That's 1. I can pick those 2. That's 1. Or I can pick these 2. That's another one. Okay, so I have 3 options. So I have 3 options to solve for this. So that's why this one was 3. So 3 choose 2 is 3. Okay, it's definitely probability. 3 choose 3. How many ways can you pick all 3 rows? 1 way. So that's how those guys work, okay? Now let me give you the math background for how you can solve that. Let's say I want to do 5, let's do that one.
Is this the theorem right here?
No, this is actually just the choose notation. There's different ways to write this choose. Now, most of your calculators have this on there. Some don't. So you might have to know the expansion formula versus just cheating on your calculator. If you have a graphing calculator, you have a button right here. Another way to write this is to have 5 things and say choose 3 things. So I have 5 objects, and I'm going to choose 3 things from it. Now, on your calculator, if you have on the graphing calculator like this, and if you don't, I'll show you a different way to get the same answer, so you'll be fine. If I hit math, the math key right there, math key has a lot of good stuff in it. And I go over to the left one, that's the PRB, probability. Notice number 3 on there is NCR. It says NCR. Okay, so NCR means I have a number, that's my total, and then the random numbers that I'm picking out of that. So I have N choose R. So if you type in 5 choose 3, that'll tell you what that value is. Okay, so 5 choose 3 is put on your calculator. So what you have to do on my calculator is you hit 5, and then you go back to that probability thing, choose 3. So it should look like this. I can just put it up here. Should look like that. 5 NCR 3. I hit 5 first. I hit math. And I go over 1 to the PRB, and then NCR.
Is 10 the correct answer?
10 should be the correct answer. Okay, so 10 should be how many different ways that I can choose 5 things. Now, if you want to double check that, there's ways to do that. So let's say I had 5 things. Let's say I had A, B, C, D, E. There's 5 things, right? And I want to pick 3 of those. And you want to try to give me all the different combinations of those 3 letters. So I could do A, B, C, right? I could do A, B, D. I could do A, B, E, right? I could do B, C, D. I could do B, D, E. Right? Could I do BAE? I already have that one, right? BAE. I've already got the combination of those 3 picks, so I can't really. So I can't do that. Yeah, order doesn't matter on these, right? Order doesn't matter. Then I can do CDE. Did I skip ADE?
Yeah.
Oh, I wasn't on there yet. I was going a different method. Yeah. You can go whichever method you want as far as coming up with your list of 10. But I was going like ABC and then AB something, and then I switched over to BCD, BCE, and then you could go CDE. And then some people are going to go like go to ACD and then ADE, and then work their list from there. So anyways, that's to come up with the list of 10 for that one. Now, as soon as those numbers get big, if I said 7 choose 4. That'd probably be a pretty big list. You wouldn't want to have to go through A, B, C, D, E, F, G, H, or however many the first 7 are and figure it out, right? You'd want to do this, right? So this guy equals 10. So that's gonna be part of your stuff. Okay. The other way to write this, some calculators don't have that button on there, right? Your $10 calculator has one?
Yeah.
Jackpot. Can I see what the button looks like?
You have to press the shift button and then.
Oh yeah, it's right there. Yeah. So most calculators actually have this button. It might be in a probability menu, like a sub list. It just depends on your calculator. If you don't have that button, you have to do this. You have to take 5 factorial divided by 3 factorial.
I have factorial in here too.
Yeah, everybody has factorial. I'm pretty sure everybody has a factorial somewhere. 5 factorial over 3 factorial. And then also on the end, you have to subtract those 2, 5 minus 3, to get 2 factorial. So this will also produce 10 for you. And I used to, one year, I made everybody do it without a calculator. But if we simplify this, right, this would be 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. So 3 times 2 times 1 is cancel. And we have 20 over 2, which is 10. Okay, so 10 is 5 choose 3 if you wanted to go through it the long way. If your calculator doesn't have that button.
Put the 2 down there.
Here, let me show you one more and you'll see the pattern. Let's say I had 6 choose 4. No. Let's say 6 choose 11. Let's say 6 choose. That's a bad one too. Let's say 16 choose 3. How about 16 choose 13? Okay.
Okay.
That'll at least be a smaller number for us. I think 6 choose 3 would be great. Okay, so I would take 16 factorial divided by 13 factorial, and then multiply by the difference between those, which would be 3 factorial. Now, to simplify is pretty easy, right? 16 factorial is 16 times 15 times 14 times 13 factorial, right? 13 all the way down. Divided by 13 factorial, multiplied by 3 factorial. So the 13 factorials cancel, right? The 3 can go in, let's see, this is 3 times 2, right? The 3 can go into the 15, that'll go in there 5 times. The 2 can go into the 14 for 7. Multiply 6, 5, and 7 together, 16, 5, and 7 together, and 16 times 5 times 7, 560. Okay, so you should get 560 for that guy. Okay, so that's the expanded version of it. Now, 16 factorial, I don't know if you can put that on your calculator. Some calculators get a little overflow crazy sometimes. It lets you, okay, some will let you do it, some won't. Just kind of depends. All right, so let me show you how we're going to expand, how we're going to use this stuff for this. Now, there's 2 patterns to look for here. The first one is the coefficients. The coefficients are using Pascal's triangle, or this new triangle that we solved for, this binomial triangle with the choosing stuff. Okay. The other pattern is what our patterns are going to be for our variables. Okay. So those are the 2 big things that you want to get out of this. So let's say I wanted to do x to the x plus y to the 5th. And I think we already know what this one is, but let me just show you the pattern for this. What's it again? No, because it's not. Well, maybe. It depends on what level it's at. Because this is. Oh, from here to here. No, it's not always going to be square. It's going to be half whatever the power is. It might be x to the 4th y to the 4th, or x to the 3rd y to the 3rd. Oh, it's going to be the 4th. It's going to be the 4th. Okay, so your binomial expansion looks like this. The first thing you want to figure out is your coefficients. Now, your coefficients, you're going to use this stuff right here. The cheater way to do it is this. Our exponent is a 5. So our first coefficient is going to be 5, choose 0. That's going to be your first term, your first coefficient. The next thing you do is you take x and you raise it to that power, to the 5th power. And then you have a y to the 0 power. I'm overkilling it on this one. Okay, overkilling it. Plus, now the next term in line, it would be 5, choose 1. That would be the next number in that Pascal's triangle floating all the way down. Now, I drop this one by 1, and I raise this by 1. So it's going to be x to the 4th, y to the 1st. Plus, the next one's going to be 5, choose 2, x to the 3rd, y to the 2nd, plus 5, choose 3, x to the 2nd, y to the 3rd. Notice my powers on my exponents always add to 5. Okay, that's a big thing. Plus, out of room here, sorry, 5, choose 4. 5, choose 4, we're going to have x to the 1st power. A little x to the 1st power, y to the 4th power. Plus, then we have 5, choose 5. And we have x to the 0 power, y to the 5th power. So that's your binomial expansion. That works for any binomial that you want to expand to any power, period, no matter what, which is kind of cool. Okay, a couple patterns to notice here. First off is this highest number right here, this power matches the exponent, and it matches this number right here. All those are going to be the same. Okay, the lower number here always matches this guy. So it's a 1 and a 1, it's a 2 and a 2, it's a 3 and a 3. That pattern always goes all the way through. The other thing to notice is my pattern number ran out right when I went 5, choose 0 to 5, choose 5. Okay, so let's go ahead and just clean this up a little bit now. First, we want to do 5, choose 5. Feel free to put that on your calculator.
1.
Or it's 1. So this is 1 times x to the 5th times 1. So my first term is x to the 5th. Plus my next term, 5 choose 1 is 5. X to the 4th, y to the 1st. So we have 5, x to the 4th, y.
Wait, did you just multiply those 2 together?
No, I did my 5 choose 1. There's 5 ways to choose one thing from a list of 5. Here, 5 choose 2. Put that on your calculator. Should be... Let me get that one. 10. Okay, so I like it. Plus 10, x to the 3rd, y squared. Plus 5 choose 3. X to the 2nd, y to the 3rd. 5 choose 4. 5. Yes. Plus 5, x, y to the 4th. 5 choose 5 is 1. X to the 0 is 1, and y to the 5th. So plus y to the 5th. Okay, so that's the binomial expansion for x plus y to the 5th. Now, this is all in general to show you what this stuff looks like with the x's and y's. Okay. Now I want to change it and use actual numbers. So let's go ahead and tweak it a little bit and jump ship and do some numbers. Let's do x minus 2 try to keep it simple for you. X minus 2, and let's go to the, how about to the third power? We'll keep it low and keep it small for you. X minus 2 to the third power. Now you could literally multiply this out if you wanted to. Please don't. You won't see the pattern, and that'll backfire for you for tomorrow for sure. Because we got to finish this up tomorrow.
Yeah.
Okay, so we get a start. It's to the third power. So that tells you where your binomial starts. You're going to start at 3, choose 0. Okay? You're always going to start with the exponent is, and start it at 0 for there. So 3, choose 0. Now we have x to the third power. And then our y, now our y value is negative 2 right there. So I actually need to take negative 2 and raise it to the 0 power. That's my second number in that term, as far as my binomial goes. My binomial is x and negative 2. Those are my two parts to that. Okay? So x and negative 2, that's what I'm going to be changing the powers on. So now I'm going to add the next term to it. So plus, I'm going to go 3, choose 1. I'm going to go x to the second power, and I'm going to go negative 2 to the first power. So I'm going to follow that pattern. I'm going to drop this by 1 and raise this by 1. Plus the next one is 3, choose 2. X to the first power now. Negative 2 to the second power. And then plus my last term in this one, 3, choose 3. So I've got 3, choose 3. X to the 0. Negative 2 to the third power. Okay, so are you seeing the pattern? Kind of for the binomial expansion? Okay, this is the general pattern all the way through. A couple things to notice is that the bottoms are the same here. That 0 is the same as this. That's the same as that. That's the same as that. That's the same as that. These guys add to that high number. Those two add to that number. These two add to that number. Add to that. Okay, that'll be a nice pattern to recognize for tomorrow. Okay. The other thing to notice is this. I have something to the third power. How many terms do I have? 4. I have 4 terms, right? Everybody notice that? I have 4 terms. Okay, so 3, choose 0 is 1. Negative 2 to the 0, anything to the 0 power is 1. So this first term is x to the third. That's my first term. Plus, I have 3, choose 1, which is 3. X to the second, multiplied by negative 2 to the first, so that's multiplied by negative 2. Which I can rewrite that as negative 6x squared. Right? We can multiply those numbers together. So we have x to the third minus 6x squared so far. Plus, 3, choose 2 is 3. X to the first, multiplied by negative 2 squared, is a positive 4. So I have a positive 12x. And then the last term is, looks like plus 3, choose 3 is 1. X to the 0 is 1. And then negative 2 to the third is a negative 8. And so multiply those together, I get negative 8. Okay, so that's your binomial expansion for x minus 2 to the third power without having to distribute and multiply everything together. You can follow that nice pattern all the way through. Okay? All right, I want to do one more, and I want you guys to give it a quick shot and see if you can get it started. And I'll jump in at the end. Here he comes, the sandpaper. No. Okay, give it a try.
Or two's thrown out.
Or just talk. One of the two. I'm okay with either.
It's going to be our homework. This is really bad.
This is your homework.
At least we understand it. This would be 4. I don't think that one.
Wow, because you put that on your calculator. Okay. Kind of overkill in the steps when I'm showing it, but you might be able to group some of it together on your calculator as you go.
Oh, I didn't notice
You're doing, oh, you're doing
Oh, okay. Sorry. No, sorry.
No, I was already.
Okay.
Okay, so I got screwed up on one.
I might have screwed up on one of them.
I'm really confused. Mine looks nothing like that.
This one?
So let's forward the over one.
96 I just did my head, so that's probably.
Oh, I can do that.
Everything looks the same until you start multiplying it together.
Yeah, I got 24
You
on
multiply
that one.
8.
Maybe I did it wrong.
I think it's
Maybe I do.
24.
Oh, I'm still getting it.
What time's 8? Is it 32?
It's 4 times.
Pretty sure I'm right.
4 times 8 times 3.
You have an extra 3 on the outside here, right?
Alright, I got.
Yeah, but okay, now you gotta watch out for this. This is kind of tricky, right? If you're taking 2x and you're raising it to the third power, you have to cube everything on the inside. So 2 cubed is 8. So that's where this 8 came from. I have the 4 sitting in the front right here for this part, right? That's why I kind of separated it out so you can see better. So 4 is this number. 2x to the third is 8x to the third. And 3 to the first is third right here, right? As I come down the line here, 4 choose 2 is the 6. 2x squared is 4x squared. I got to square that 2 as well, right? And then the 3 squared is the 9.
Okay, yeah, I just did the 4 times 2.
It's kind of like you wouldn't have got the 16 then either, would you? Did you miss the 16 part then?
Yeah.
Okay, yeah, because it's 2x to the fourth. You have to raise that 2 to the fourth as well.
Okay.
Alright, I see what I do.
Okay.
Oh,
So I'm pretty sure this is
That's
right.
right.
Unless you
Yeah.
have something else to find
No,
out.
no, I got it.
So I'm
Just looking.
okay, so how did
soaking
you
it all in,
16x to the
right?
fourth?
Yeah.
What's that?
How'd you get 16x to the fourth?
How did I get 16x to the fourth? Because 4 choose 0 is 1, right? 2x to the fourth, 2 to the fourth is 16, and then x to the fourth, x to the fourth, and then 1 to that guy.
Oh, got it.
All right, so that's the beginnings of the binomial expansion.
Last
Okay. Good. All right, cool. So we are on homework.